So welcome to In-Floor Heat Plumbing 101. I'm not a YouTube influencer, so you're gonna have to do without the smash the like button. And how's it going, guys? But that being said, I just want to go through a little bit of what we've got going on here, how I got there, and some of the problems that I've had along the way. And hopefully it will be able to help somebody out who's also going on this plumbing adventure. And so let's start with some of the basics of the system. We're going to go over all the different components involved here, and just to give you a general overall idea of what you might need if you want to put something like this together, starting from scratch like I did. So we'll cover the basic components first. You probably, if you're watching this video, you're going to know what all this stuff is probably, but we'll just touch on it real quick. So we got our boiler over here, 150 kBTU natural gas boiler. Natural gas line coming in here. We got our shut-off, our union, and then the gas goes into up the top there. I've got 3-inch CPVC exhaust and intake piping. I just bored a hole through the wall. I destroyed one of my hole saw bits on the hardy board siding, so if you got hardy board siding, prepare to buy a new hole saw bit. That stuff's hard as rocks. What our water is going to do is going to come, after it boils up in the boiler, it's going to come out of the boiler, go through our air water separator. We got a little air valve on top here. I didn't know what these were until I went and did some poking around on YouTube, and I got a whole bucket full of parts when I bought this thing used, and I didn't have really much idea what any of this stuff was, but I got it all figured out, and it's more or less working right now. So air water separator gets rid of any air in your system. We got our pressure gauge. Right now I'm running 20 psi just to keep the boiling temperature up there, so I don't accidentally boil anything over, because my boiler is a little bit overrated for this system. So we got our one inch pipe after it comes out of there. Safety valve, super important if you don't want to make an explosion. Got our hot water comes out of here. Down here, I'm not sure if you can see it or not, but we got a taco pump down there. I think that taco pump's a little bit oversized for this system, but it was used and I found a good deal on it, so that's what I'm using. We get your Uponor manifold system for radiant floor heat and other applications like this. Really expensive, but I am super impressed with how well the PEX just goes into this. The fittings are no muss, no fuss. Super easy to hook stuff up and disconnect it, and it doesn't leak. So it's pretty much foolproof that way. Then you got your little flow control valves. Tells you how much fluid you're passing through the system here. These 3 loops are for in-floor heat. We got our isolation solenoids on these, and when we get a call for in-floor heat in the garage, these solenoids, they're normally closed, they pop open, and of course everything else is on. You get your hot water going down into the floor. The 3 loops on this side, I bought a bigger manifold in case I wanted to add some stuff later, like zone control for the offices, or heating a hot tub, or melting ice and snow off the pad in the back, which hasn't been poured yet. But right now, what I've got going on here is 2 of these loops merge into one, and then they come up here and they go into our water to water heat exchanger for the hot tub. So this is your plate heat exchanger. It's a 14 plate heat exchanger, and I got a Grundfos pump up here, which is a nice little quiet efficient pump, and my hot tub loop on the isolated hot tub side is 3/4 inch PEX, and then the hot water coming up to the heat exchanger is 1/2 inch PEX, and that's a little bit of a problem. I am going to need to add another heat exchanger up there with 3/4 loops on both sides, because I'm just not getting enough flow through to keep the heater happy. It's cutting in and out, trying not to boil over. So we're going to have to add another heat exchanger to add to the capacity there. That's pretty much it for this system. Of course, you got your expansion tank here. A little bit of fooling around trying to get that thing to get the right amount of water and air in it. It's got a rubber bladder in there. You can kind of hear it moving when you pump it full of water or pump it full of air. Another little air valve up here to let some air off the hot tub loop side, which completely doesn't work at all because the hot tub is open, and every time you open up that air valve, it just sucks in some more air. So that's a completely useless air valve. I gotta figure out what I'm gonna do with that. But I pulled this heat exchanger out of a pre-made tankless hot water heater, and so it's got a bunch of funny valves and connections that really you can't work with unless you get specialty materials. So I just kind of left all those systems in place and made it work. So that's the basic overall system. You got your boiler, your pump, your solenoid valves. Got 4 solenoid valves, your expansion tank, and your heat exchanger for the hot tub zone. So in the next video, we're going to just take a little bit of a closer look at some of these items and how they work and all the kinds of trouble you get into. Oh, and I didn't mention one very important component in this system. This bucket down here, this is a bucket of my tears. This makes everything go. As you can see, it's only half full, so I suspect that this system's got a lot of headaches left in it before it starts working exactly the way we want it to. But yeah, also talking about the bucket, we were being geniuses when we designed the floor, and we forgot to invent a condensate drain. And so now we carry buckets of water out every week, which is kind of a pain, but I really can't think of any better solution for it, because I don't want my condensate dripping out into the great outdoors and then freezing solid when it gets down to like -30, -40, -50 in the wintertime here. So if you have a clever idea about that, do let me know. Okay, so for part 2 of this video, for those of you that wanted to see how we invented the natural gas heated hot tub in this application, we're just going to go outside to the sunroom and see where all of that stuff ends up. Ugh, it's snowing again. Okay, so on the outside here we got our exhaust and intake for the boiler, and under all this mess here we've got insulated PEX piping running up into the sunroom, and you can kind of see the 2 insulated PEX lines going up into the sunroom there. I drilled a hole through the concrete and made that work back in the summer. Okay, so it's a bit of a disaster in here because I had a flood yesterday when I was trying to build something inside here, and here you can see the lines coming up into the hot tub there. That's your hot water in, and your not so hot water going back out to the boiler to get boiled again. And okay, so what we got going on in here is a bit of a rat's nest, but these are your lines coming in from the boiler. One's just a little bit warmer than the other. This is your fill valve to fill the hot tub as well as get some air out of the system. And our circulator pump is missing right now. I don't know if we can see that, but that blew up on me, and I've got to find a new one of those. So right now this hot tub is just heating, it's not circulating. But what we got here is a little 120 volt relay trying to run off of one leg of the 220 volt. I'm not going to touch it, but you can see it in there. 220 volt power lugs that used to run the electric heating element. So when there's a call for heat, theoretically this relay will kick in and the signal goes out on this wire to the garage, and that turns the boiler on. But unfortunately we got some issues right now with these heating sensors. So there's a heating sensor upstream of the
now missing heating element and a temperature sensor downstream of the non-existent heating element. And what these things do is they tell the computer that there's a call for heat, and the element turns on and the water's flowing this way, and when the water reaches this downstream temperature sensor, it's reading hot water, whereas the upstream sensor is saying I still got cold water coming in here, so everything's working like it should. Now, because we don't have a heating element, there's no differential in these temperature sensors, and so my computers become extremely grouchy and just throwing a bunch of codes and causing all kinds of problems like that. So I got to figure that out. When I figure that out, we'll post part 3 of this epic video series.